Hello scholars, today we're going to do multiply and divide rational functions. So get your notes out. Let's go. Bell word. My daughter Gia is learning about fractions. Well, she's 5, so she probably shouldn't, but oh well. We need to help her out with her homework. She has to do each of the following problems as well as 96 others. Without using a calculator, let's go back to our elementary school days and solve each fraction problem. Show your work and explain how you got your answer. All right, so multiply 3 over 5 times 1 over 5. How do you multiply two fractions? You multiply across, right? So 3 times 1 is 3. 5 times 5 is 25. Yeah, is it coming back to you? All right, what about multiply 7 over 8 times 3 over 7? So unlike the first example where I can't cancel anything out, look at the second one. Is there anything I can cancel out? Is there any common factor that is on the top and the bottom? Yeah. Do you see 7s? So can I cancel those out? Yes, I can. So I have 3, 8. How do you divide? Oh yeah, dividing is same as multiply by the reciprocal. Reciprocal of 511 is 11 over 5. Remember that? So now the division problem becomes the multiplication problem, and then you can cancel out the 11, both top and the bottom, and 8 fifths. Oh yeah, 5, 6 divided, multiply by the reciprocal, 7 over 15. What about this time? There's nothing common top and the bottom that goes in as it's obvious, but you know that 5 and 15 both are divided by 5, so I can reduce, divided by 5, 1, 3. Is there anything I can cancel out? Nope. And then multiply across. 7 over 18 is the correct answer. So explain to Gia how you're going to multiply and divide. To multiply, what do? You multiply numerators and denominators together, right? So whatever that's there, you multiply. Whatever that's there, you multiply together, top and the bottom. That's it. I shouldn't put multiply. What about divide? So if the problem is that divided by, I don't know, star over triangle, you're going to make that as a multiply by the reciprocal problem and then go from there. Cool? Okay, so let's look at a little different example here. Miss Hill's cousin Odd is learning about rational function. So you might be wondering, what is a rational function? It's same as a fraction function. So there's a function. Why is this function? Because there's x in it and it has to do with the fraction. We need to help her out. So let's go. The process is going to be very same. When you multiply, if there's any common factor top and the bottom, you can cancel out. Do you see over here you have x plus 3 top and the bottom? Yes, so you can cancel out. You're left with 1 over x plus 5. Now over here, please be careful. Do you think I can do this? X plus 3 over x plus 5. Oh, I can cancel those ones out. Can I do, excuse me, I can cancel those x's out. Can you cancel those x's out? No, I can't. Why not? Because x is not a factor of x plus 3. It's like this. If you have 2 plus 1 over 3 plus 1, can you cancel those ones out? Nope, because they're added, right? It has to be multiplied in order for you to cancel out. So please note that. Letter B, multiply this. Is there any common factor? I don't see it, so it'll just be multiply across. So 7 times x plus 1, a numerator, denominator, x plus 8 times x plus 6. Divide, just like the top one, dividing problem becomes the multiply by the reciprocal. So do you notice how I flip it up in the bottom? Yeah. Is there any common factor? Yeah. X minus 11 is both the factor of the top and the bottom. So it's going to be 3x plus 8 over 2x minus 5. What about here? 6x squared over x plus 1 multiplied by the reciprocal, x plus 1 over x. Now let's see what happened. I have x plus 1 here. I have x plus 1 as a factor, top and the bottom. Cancel. Now what about here? There's an x squared. There's an x. Can I cancel those x's out? Answer is yes this time. Why? Because x is being multiplied here. This is a factor. Whereas over here, x wasn't a factor. It was just added. Okay, so I can cancel those x's out and then multiply across. I'm left with 6x. Okay? So it's the same thing. That's what I'm trying to say here. It's the same thing. Don't afraid of the variables versus the numbers. So, how do you multiply and divide rational function? Let's talk about the multiplying first. Step number 1. Factor both numerator and denominator if necessary. Step 2, and I'll explain this when we do the examples. Cancel out any common factors in denominator and numerator. Step 3, multiply across. Dividing. Very similar, right? But before you do anything, step 1 will be rewrite as multiply by reciprocal. I love how to spell that, reciprocal. And then it's the same thing, same step. So dividing is same as a multiplying, except you have to do the first step. So let's go. Multiply the rational function. Ooh, look at that, look at that. All right. It's a rational expression because all the x's are there and it involves with a fraction. Please don't be afraid. Okay, we got this. What are we going to do? Step number 1, I want to make sure I factor everything as much as possible. So let's look at one at a time. X plus 2, can I factor that further? No, x plus 2 is x plus 2. Look at the denominator over here. I got x squared minus x minus 20. Do you think you can factor? Speaking of factor, we got to review something. Okay, so pause, go back over here. How to factor. I'm going to bring up the stuff we learned from the last semester. How to factor. Always do the greatest common factor first. And then we learn a bunch of things. We learn about ACB chart. So when you have a trinomial, meaning there are 3 terms, you try to ACB chart. What else? Difference of 2 squares. So a squared minus b squared is a plus b times a minus b. We learn about some difference of 2 cubes. That's a big formula we learn. We learn about grouping. And we also learn about the synthetic division given factor. Sorry, my handwriting's bad, but you got that point. Okay. Okay, so go back here. I can't factor x plus 2 out. What about x squared minus x minus 20? That is a trinomial, 3 terms, 1, 2, 3. So I'm going to attempt ACB chart. Let's try that. X squared minus x minus 20. So let's factor that. GCF is 1. A times c is negative 20. B is negative 1. Find 2 numbers, multiply to that. Negative 5 and 4. So x squared minus 5x plus 4x minus 20. Remember, you split the middle term. Factor 2 at a time. X minus 5 plus 4, x minus 5. It'll be x minus 5. X plus 4 is how you factor that denominator. You could have taken shortcut using those 2 numbers. Why can I take that shortcut for this factor? Because a is 1. But if you didn't know it, that's fine. Alright, so that's how you factor the denominator. Alright, look at this numerator over here. 3x squared minus 21x plus 30. What do you think? Do you think you can factor that? Absolutely. GCF is 3. X squared minus 7x plus 10. ACB is 10. B is negative 7. 2 numbers, negative 5 and negative 2. What's the value of a here? 1. So I actually can do the take a shortcut. It'll be x minus 5, x minus 2. Don't forget to include that GCF there. Whew. What about this denominator? GCF is 3. X squared minus 4. Can I factor x squared minus 2 further? X squared minus 4 further? Oops. Yes, that is difference of square, square. 4 is what square? 2 square. So it'll be x plus 2, x minus 2, right there. Okay, so I factor everything. Now we're going to put it back together. Trying to find a different color. There you go. So what do I get? I get x plus 2 over x minus 5 times x plus 4 times the numerator was 3 times x minus 5 times x minus 2 over 3 times x plus 2 x minus 2. So really, this unit is asking you, do you know how to factor? Like, that's what it is, all right? And don't forget to include the greatest common factor, because that's the easy to forget about it. Okay, so I factor everything. Now what do you do? The fun part. Cancel out the common factor. 3. That's a common factor because it's multiply. What else? What else do you see? X minus 2, x minus 2, x plus 2, x plus 2, x minus 5, x minus 5. So all I have left is 1 over x plus 4. How about that? Okay. All right, let's do one more. Divide a rational expression. So if you look at the top of your notes, dividing is same as multiplying, except one extra step at the beginning, which is to rewrite as a multiply by the reciprocal. All right, try it, and I'll be back. Okay, so there we go. I rewrite it as a multiply by the reciprocal of the, right there. Yep. Now what? Factor everything. Factor everything. If you want to, you can stop the video and try it, and then come back. X squared minus 6x minus 55, trinomial, ACB chart, GCF is 1. Multiply to the negative 55, add up to negative 6, negative 11, and 5. A is 1, so I can actually take a shortcut. It'll just be x minus 11, x plus 5. Okay, so x minus 11, x plus 5. What about the denominator? How do I factor 2x minus 8? GCF is 2. X minus 4. How do you factor x minus 4? I can't. X minus 4 is x minus 4. What about x squared minus 14x plus 33? Probably ACB. Negative 11 and negative 3. Yep. So I can take a shortcut since a value is 1. If you don't believe me, that's fine. You can do it. Split the middle term, factor 2 at a time. X minus 3, x minus 11, x minus 3, x minus 11. Okay, so does it look like I factor every single thing? Yes, I did. Then let's go. The fun part, right? It's always the fun part. Cancel common factor out. Anything else? I don't think so. So x plus 5 over 2 times x minus 3 is what you get.